Hello and welcome to another of my videos on chemistry. This video is on the metric system, or rather metric conversion, dealing with units from Pico to Tera. The Nevada State Science Content Standard says that students know tables, charts, illustrations, and graphs can be used in making arguments and claims in oral and written presentations. And the objective of this video is that presented with various measurements, students will correctly use and convert metric units. So here I've created a table with the smallest metric units at the top, and as you go further down, the units get bigger and bigger. So picometers, for example, could be used to measure the bond length between two atoms, the distance between the nuclei of two separate atoms that are bonded together. Nano could be used in nanometers when discussing such things as the wavelength of various light energies in that region. Micro, you deal with these every day. You may not realize it. A microwave oven is named after the wavelength of energy that is used to heat up your food. Millimeters, or I keep using meters, but I could actually use any of these base units, millimeters, milliliters, milligrams, and that's the same for any of these prefixes. But milli, it becomes a more commonly used and seen in society. Millimeters, there's 1,000 of these for every base unit, for every meter, or for every liter, or for every gram. Centimeters, again, you become familiar with these as they get bigger. Decimeters, there's 10 of these per meter. And here we have our base units. No reason for that to be there. Okay, there we go. Our base units, meter is length, liter for volume, gram for mass. And here, as we continue getting bigger, we have deca, and the numbers over here might start to get confusing. But if you think about it, okay, let's go back up here to see this pattern. When we look at milli, it takes 1,000 milliliters to equal 1 liter. It takes 100 centiliters to equal 1 liter, and 10 deciliters to equal 1 liter. So if we go the other way and we look at these bigger units, every 1 meter is equal to a tenth of a decameter. Or why don't we use something a little bit more familiar? Most people are familiar with kilometers. It takes one meter is equal to 1,000th of a kilometer. Or in other words, it would take 1,000 meters to equal 1 kilometer. So as we go through, you start to see the pattern here with these numbers. At the top of the column I put that are equal to 1 base unit. Each of these is what would be equal to one of these base units right here. So these come in handy later when we're doing conversions, in that the number of zeros or the number of decimal places you have to move to make this be a 1 will help you to know how many decimal places you'll have to move when we're doing our conversions. And that may not make complete sense right now, but it will in a slide or two here. So let's move on. We're going to move to converting metric units. When we convert small units to big units, it means that the number actually gets smaller, and here's half of the chart that we had earlier. If we look here, let's say we're going to convert, I used this earlier, let's say we're converting from millimeters to meters. Now, milli is a smaller unit than a meter, so that means we're going from a small unit, milli, to a big unit, a meter, and the number should get smaller. So let's look here. We have 1,000 millimeters, and it's equivalent to 1 meter. And the number certainly did get smaller there. Okay, so let's go on to some examples that aren't quite as obvious as these, and that are more practical. Okay, again, we have our statement that small unit to big unit means the number gets smaller. So if we have 452 centimeters, okay, if you look back at our chart, here it is, had 2 zeros. We would have to move 2 decimal places to make that be a 1. So here, to go from centi to meters, we have to move 2 decimal places. In fact, I could show it this way. Let me show it this way. Centi, we move 2 places. And meters is a base unit, so we don't have to move any decimal places. So I'm going to put a 0. So how far apart are these? They're 2 decimal places apart. So I'll just write this 2 over here, which means we're going to move 2 decimal places, change this number by 2 decimal places, and make it smaller. So if we start right here, we're going to have 1, 2. So our answer should be 4.52. And if we uncover our answer here, 4.52. Okay, so let's try that with another one. Let's go with a different color here. Okay, so we have picometers, and if we look back at our chart here, pico is associated with 12 decimal places, 3, 6, 9, 12. Okay, so we have 12 decimal places. So I'm going to put a 12 above the pico. And over here we have millimeters. Okay, milli is a small m. Milli, if you look back again, milli, here we have 1, 2, 3 decimal places. So let's put a 3 right there, 3 decimal places or 3 zeros. Okay, so 12 and 3 are 9 decimal places apart. So when we convert units, we're going to move 9 decimal places, making this number get smaller. Okay, so we're going to go 1, 2, 3, and I could keep drawing them in, but I'm just going to put 6 zeros in front of that, plus these 3 is going to make 9. So here we have, keep that uncovered, okay, here we have our answer. 0.60147 millimeters is equal to 147 picometers. Okay, so here we have micrograms. A U stands for micro. Micro, you have 6 decimal places. Deci is 1 decimal place. So between those, if we're converting from one to the other, we're going to move 5 decimal places, which means this number is going to get smaller by 5 decimal places because we went from a smaller unit, micro, to a bigger unit, deci. So the number gets smaller by 5 decimal places. So we uncover that one, and there's our answer, 5 decimal places smaller. 1, 2, 3, 4, 5. Okay, nano. If you don't have that chart, this one written down, I would recommend keeping that in your notes because when you get an assignment, that's going to be handy to have. Okay, it tells you how many decimal places to move. Now I've hidden my answers again. Here we go. Okay, so nano. If you look at your notes, you will see that nano gives you 9 decimal places. And liters is a base unit again. So let's just write in a 0 for that. And between these two, we're going to move 9 decimal places, making this number smaller. So we have 1, 2, 3, 4, 5, and we need to put 4 more zeros in front of that to complete our answer. 2, 3, 4.25. Now, it's not incorrect to write these zeros right here at the end, but they're really not needed, so I'm not going to bother with them. Okay, let's do the last one. Okay, we have milligrams, and milli is associated with 3 zeros or 3 decimal places, and deci is associated with 1 decimal place, which was 1 0. Okay, so the difference between these is going to be 2. We're moving our decimal. So we're going to move our decimal 2 places, making this number smaller, and so our answer, we actually end up with more zeros in front of this 4. We end up with 0.00004 decigrams. Okay, so that's converting smaller units to bigger units. What if you need to go the other way? a big unit to a small unit. And this is the other half of the table that we had earlier. So let's look here. The bigger units are at the bottom, and they get smaller as you go up. So if we converted megaliters to decaliters, we don't even have to go to base units to do this. Let's go megaliters to decaliters. Okay, if we have this many megaliters, it's going to be equal to that many decaliters, tenth of a deciliter. All right, so let's try some that are more practical. The number gets bigger because 0.00000 is definitely smaller than 0.1, a tenth. Okay, now these are a bit more like what you would see on your assignment. Okay, big unit to a small unit, gigagrams is definitely bigger than grams. So again, giga is associated with how many decimal places? Okay, we go back. Giga, you've got 3, 6, 9 decimal places. So we're going to put a 9 here by giga because it's associated with 9 decimal places. And grams is a base unit, so I'm just going to put a 0 there. So between them we have 9 decimal places. So if I uncover it, we've changed this number to a bigger number, moved 9 decimal places. I think you're starting to catch on to this now by this point. So this one here is again going to get bigger. I'll just do one more here and then I'll just start uncovering the rest of these answers for you. Okay, mega, capital M is mega, little m is milli. Don't get those confused. Mega is 6 decimal places and kilo is we're talking about 3 decimal places. So for a difference of 3 decimal places, we're going to move this 3 decimal places, making the number bigger. So we end up with 0.082. We move the decimal 1, 2, 3 over to right here. We have 0.082. Okay, now if you want to attempt the rest of these on your own, feel free to stop the video. I think what I'm going to do at this point, just in the interest of saving time, is just uncover these and you can compare your answers with what I have here. So there's the first one, addition of 10 zeros. So there's 10 decimal places between those. This right here, uncover it, the number gets bigger by 2 decimal places, kilo to deca. And we have tera to deca. That's quite a difference. And we'll have, what do we have here? 9 zeros behind it. Okay, so that pretty much gives you the concept of going from bigger units to smaller units. And we just have to mention one more thing. Now, when you get an assignment on this, you're not necessarily going to be told which is a bigger unit or which is a smaller unit. Like I had them grouped nicely before. You could have to do either one of them. So let's just look at these here. And I will actually work through one more of these. This one you should be able to figure out on your own. I'll uncover it in a minute. But this one right here, it's a little different than what we've done thus far. Okay, and I'll show you why. Let's work through this. Okay, we have megameters, and mega is associated with 6 decimal places to one side of the base units, and milli is associated with 3 decimal places on the other side of the base units. Now, if you look at what we've done before, let me just go back here to, here we are. Okay. Whenever we've done conversions before, we had just stayed like on this side above when we were converting above the base units, or we stayed below the base units. In other words, we would convert from giga to kilo, or from hecto to tera, or we may have done conversions up here. But we did this time. What we're doing, we're going from mega, which is below on this chart. We're going to go 6 places to get up to the base units, but then we keep going to milli on the other side, 3 more decimal places. So actually what we end up with is instead of subtracting them, the difference between them, we really have to add this. So we end up with 9 decimal places, and the number does get bigger. So what we end up with for an answer, 9 decimal places means you put 9 zeros behind that 15. So it's pretty big. So that should make sense. These other ones you should be able to do. They're really no different than what we've done before, just looking at your rules. Small unit, or excuse me, bigger unit to a smaller unit, your number gets bigger. by 2 decimal places. And here we have a small unit to a bigger unit, so the number should get smaller. And there we have a smaller number. Okay, these down here, you may or may not see these on an assignment, and if you see a circle, all it means is fill in which one is greater than or less than, or if they're equal. So 630 milliliters is definitely smaller than 6 liters, and 1700 centimeters is actually the same as 1.7 decameters. Okay, so there's our video on metric conversions, and you'll be using this as we go through the term. It's kind of a basics, one of the starter videos we're going to have for the course, and I hope this helps you out and you understand how to do the assignments. Talk to you next time, and we'll talk about scientific notation. We won't have to deal with all these zeros, or it's sort of a shortcut in writing those. Thanks for watching.